Architectural drawings at a 1:50 scale are used for electrical planning to provide a precise and scaled representation of the architectural layout. The purpose is for use in electrical planning and design. A 1:50 scale means that one unit on the drawing represents 50 units in real life. For example, if a wall on the drawing is 10 units long, it would be 500 units, that is 50 times 10 long in reality. Elements to include are firstly the building outline, that is the exterior walls of the structure, including doors and windows. Secondly, interior walls, including partitions, closets, and openings. Thirdly, ceilings, including height, slopes, and any architectural details such as beams, bulkheads. Fourthly, stairs and elevators, and their location and configuration. Fifthly, equipment locations, that is major appliances, fixtures, and machinery such as refrigerators, stoves, and heating, ventilation, and air conditioning units. Guidelines for use are firstly, create a separate layer by assigning a dedicated layer in the computer-aided design software for the 1:50 architectural drawing to avoid confusion with other drawings. Secondly, match the scale, ensuring that the architectural drawing is at the correct scale, that is 1:50, to match the electrical plan. Thirdly, use symbols, utilizing standard symbols for electrical components and fixtures to ensure clarity and consistency. Fourthly, label elements, providing clear labels for walls, doors, windows, and other elements to facilitate communication. Fifthly, coordinate with other drawings, cross-referencing the 1:50 architectural drawing with other plans such as floor plans and heating, ventilation, and air conditioning plans to ensure accuracy and minimize discrepancies. There are benefits of using a 1:50 architectural drawing. Firstly, it provides a precise and scaled representation of the architectural layout. Secondly, it aids in the planning and design of electrical systems. Thirdly, it facilitates coordination between electrical, architectural, and other disciplines. Fourthly, it reduces errors and conflicts during construction. Electrical plans utilize specific symbols and notations to represent electrical components and wiring. It is crucial to understand these symbols to accurately interpret and implement the electrical design. Electrical plans often show lighting layouts, power distribution, and control systems. These plans are essential for ensuring that electrical systems are installed safely and efficiently. Architects and electrical engineers collaborate closely to integrate electrical systems seamlessly into building designs. This collaboration ensures that electrical needs are met while maintaining the aesthetic and functional integrity of the building. Codes and standards, such as those set by the National Electrical Code, or NEC, govern electrical installations. Compliance with these codes is essential for safety and legal reasons. Electrical plans must adhere to these codes to ensure that the electrical systems are safe and reliable. The scale of 1:50 is commonly used in architectural drawings because it provides a balance between detail and manageability. This scale allows for accurate representation of building elements while keeping the drawing size reasonable. Other scales may be used depending on the specific requirements of the project. For example, a 1:100 scale might be used for larger buildings, while a 1:20 scale might be used for detailed sections. CAD software is widely used for creating architectural and electrical plans. CAD software allows for precise drafting and easy modification of drawings. Popular CAD programs include AutoCAD, Revit, and ArchICAD. These programs offer features specifically designed for architectural and electrical design. When creating electrical plans, it is important to consider the load calculations for various circuits. Load calculations determine the amount of power that each circuit will need to supply. This information is used to select the appropriate wire sizes and circuit breakers. Accurate load calculations are essential for preventing overloads and ensuring the safety of the electrical system. In addition to power distribution, electrical plans also show communication systems such as telephone, data, and security systems. These systems are an integral part of modern buildings and must be carefully planned and integrated into the overall electrical design. The location of outlets, switches, and lighting fixtures is critical for the functionality and usability of a building. Electrical plans specify the placement of these elements to ensure that they are conveniently located and meet the needs of the occupants. The height of outlets and switches is also important, especially for accessibility. Electrical plans should indicate the mounting heights for these devices to comply with accessibility standards. Proper grounding of electrical systems is essential for safety. Grounding provides a path for fault currents to flow back to the source, tripping the circuit breaker and preventing electrical shock. Electrical plans show the grounding system, including the location of ground rods and the routing of grounding conductors. Surge protection is another important consideration in electrical design. Surge protection devices protect electrical equipment from damage caused by voltage spikes. Electrical plans may show the location of surge protection devices at the service entrance and at individual circuits. Lighting design is a key aspect of electrical planning. Lighting plans show the type and location of lighting fixtures to achieve the desired illumination levels and aesthetic effects. Lighting design should consider energy efficiency and the use of lighting controls to reduce energy consumption. Emergency lighting is required in many buildings to provide illumination during power outages. Electrical plans show the location of emergency lighting fixtures and the backup power system that supports them. Fire alarm systems are also an important part of building safety. Electrical plans show the location of fire alarm devices such as smoke detectors, pull stations, and horns. The fire alarm system is typically connected to a central control panel that monitors the system and alerts the fire department in case of an emergency. Coordination between the electrical plan and other building systems is crucial for avoiding conflicts and ensuring that all systems work together effectively. This coordination requires close communication between the architect, electrical engineer, mechanical engineer, and other consultants. Regular meetings and reviews of the plans are essential for identifying and resolving potential conflicts. Building Information Modeling, or BIM, is increasingly being used to coordinate building systems. BIM is a digital representation of a building that includes all of its physical and functional characteristics. BIM allows designers to visualize the building in 3 dimensions and identify potential conflicts between systems. Changes to the electrical plan may be required during construction due to unforeseen conditions or design changes. It is important to document these changes and update the electrical plan to reflect the as-built conditions. The as-built electrical plan is a record of the final electrical installation and is used for future maintenance and modifications. The voltage drop in electrical circuits is an important consideration in electrical design. Voltage drop is the reduction in voltage that occurs as electricity flows through a wire. Excessive voltage drop can cause equipment to malfunction or overheat. Electrical plans should include calculations to ensure that the voltage drop is within acceptable limits. Conduit is used to protect electrical wires from damage. Electrical plans show the location and size of conduits. The type of conduit used depends on the application and the environment. Common types of conduit include rigid metal conduit, electrical metallic tubing, and flexible metal conduit. Junction boxes are used to connect electrical wires. Electrical plans show the location of junction boxes and the number and size of wires that are connected in each box. Junction boxes must be accessible for maintenance and inspection. Electrical panels are used to distribute electricity to different circuits. Electrical plans show the location of electrical panels and the circuit breakers that are installed in each panel. The size of the electrical panel depends on the total load of the circuits that it serves. Transformers are used to change the voltage of electricity. Electrical plans may show the location of transformers and their voltage ratings. Transformers are often used to step down the voltage from the utility company's distribution system to the voltage that is used in the building. Motor control centers are used to control electric motors. Electrical plans may show the location of motor control centers and the components that are installed in each center. Motor control centers typically include motor starters, overload relays, and control transformers. Power factor correction is used to improve the efficiency of electrical systems. Power factor is a measure of how effectively electrical power is being used. A low power factor can cause increased energy consumption and reduced equipment capacity. Electrical plans may include power factor correction capacitors to improve the power factor. Harmonic distortion is a problem that can occur in electrical systems. Harmonic distortion is caused by nonlinear loads such as electronic devices and variable frequency drives. Harmonic distortion can cause equipment to overheat and malfunction. Electrical plans may include harmonic filters to reduce harmonic distortion. Uninterruptible power supplies, or UPS, are used to provide backup power to critical equipment during power outages. Electrical plans may show the location of uninterruptible power supplies and the equipment that they support. Uninterruptible power supplies are commonly used to protect computers, servers, and other sensitive electronic equipment. Ground fault circuit interrupters, or GFCIs, are used to protect people from electrical shock. GFCIs detect ground faults and trip the circuit breaker, interrupting the flow of electricity. Electrical plans show the location of ground fault circuit interrupters in areas where there is a risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. Arc fault circuit interrupters, or RFCIs, are used to protect against electrical fires. Arc fault circuit interrupters detect arc faults, which are dangerous electrical arcs that can occur in damaged or worn wiring. Electrical plans may show the location of arc fault circuit interrupters in bedrooms and other areas where people sleep. The selection of electrical equipment should be based on the specific requirements of the application. Factors to consider include the voltage, current, power, and environmental conditions. Electrical plans should specify the equipment that is required for each application. The installation of electrical equipment should be performed by qualified electricians. Electricians must follow all applicable codes and standards to ensure that the installation is safe and reliable. The electrical plans should be followed carefully during the installation process. The inspection of electrical installations is important to ensure that they are safe and comply with all applicable codes and standards. Electrical inspections are typically performed by local building inspectors. Electrical plans should be available for review by the inspector. The maintenance of electrical equipment is essential for ensuring that it continues to operate safely and reliably. Electrical equipment should be inspected and tested regularly. Electrical plans can be used to locate and identify equipment that requires maintenance. Energy efficiency is an important consideration in electrical design. Energy-efficient equipment and lighting can reduce energy consumption and save money. Electrical plans should specify energy-efficient equipment and lighting. Renewable energy sources, such as solar panels and wind turbines, can be used to generate electricity. Electrical plans may show the location of renewable energy systems and the connections to the building's electrical system. Smart home technology can be used to control lighting, appliances, and other electrical devices. Electrical plans may show the integration of smart home technology into the building's electrical system. Electrical safety is paramount in all aspects of electrical design and installation. Electrical plans should be designed and implemented with safety in mind. All electrical work should be performed by qualified electricians.